for the homework that I assigned. I asked you guys to do in the exponential log graphs packet, numbers 1 and 4. I'm going to go through those, and I have one other one for us to practice, and then I have a little more log graphs and exponential graphs for homework. The very first one is f of x equals log base 2 x plus 3 minus 4. So first thing I do is I come up with a parent function. Now the parent function for this is going to be basic y equals log base 2x. So I'm going to want to make a basic xy table for this guy. And to do that, I have to bend it. So it's 2 to the y equals x. So I'm going to make an xy chart. Now, whatever variable's in the exponent, in this case it's y, that's what we fill in first. So I'm going to do 1 negative, 0, and 1 positive. You could use negative 1, 0, 1, negative 3, 0, 3, and so on. Plug that in, I get 1/4, 1, and 4. Okay. Now, the asymptote for any log graph is going to be x equals 0 for any basic log graph. Now what we want to do is do f of x, which is this guy here. So I'm going to make a new xy chart, and I'm going to work from left to right. Now it's log base 2. The first thing we come across is the x plus 3. That means I want to subtract 3 away from each of my x values. So 4 minus 3 is 1. 1 minus 3 is negative 2. And 1/4 minus 3 makes negative 2 3/4. Okay. Then the minus 4 hanging off the end is what I want to do to the y's. So it's 6, negative 4, and negative 2. And the new asymptote, right, anything we did to the x column is what we're going to do to my asymptote because it's x equals. That means I have to subtract 3. So that means x equals negative 3 is my new asymptote. So here we go. I'll graph in blue. 1, 2, 3, negative 3. So I get a vertical asymptote at negative 3. And I'm going to graph these points. 1, negative 2. So over 1, down 2. This guy there. Back 2, down 4. And then up here, and then down 6. So right about there. So my log graph looks like that guy. All right, so I'm going to use that now to find domain and range. Now domain is left to right, so look how far to the left we're going. We're blocked at negative 3 here. And we don't actually ever hit it, so it's going to be soft bracket, negative 3. To the right, it's an arrow, so we're going to go forever. Range is how low to how high. We go down forever and up forever. So those are my domain and range. Now, I want to find the inverse. And then I look further down, and then I want the domain and range for the inverse, which I'm hoping you realize we have already. Just switch your x and the y, right? So this is going to be negative infinity, infinity. Negative 3. Infinity goes there. So now we're going to do the inverse part. All right, so the original equation, if I wrote it as y equals, is log base 2 x plus 3 minus 4. First step in inverse, switch the x and the y. And then we have to get the y isolated again. So I'm going to add over the 4. Now, at this point, look at this equation. Notice we have a singleton log. That means we're going to bend it. So I'm going to bring this up here. The base is 2, right? The exponent is what it's equal to. So x plus 4 is equal to y plus 3. Then subtract the y over. 3 over, sorry. So to find the inverse, that answer is going to be f negative 1x. We have to use function notation. Equals 2 to the x plus 4 minus 3. And that's what would go on that line. So that's the key to the first question. How'd you guys do? Now, I'm going to go over the number 4. Now, before I jump into number 4, which is f of x equals 3 minus 2e to the x, I don't like the way it's written. I prefer to see it f of x equals negative 2e to the x plus 3. I'm going to write it like that instead to get it in the correct order. And then I'm going to come up with the parent function. So let's do this way over here. So the parent is going to be y equals e to the x, plain old e to the x. And I'm going to make an xy chart for that. Now notice this time, there's an x in the exponent. So my 3 numbers go down the x column. So this would be 1 over e, 1 and e. Now, don't use 2.7. That's what you're going to think in your head when you're doing it. When you're actually putting these down on paper, you want to use the e's. Now, what is the asymptote for a basic exponential equation? And instead of x equals 0, it's going to be y equals 0. So that's the basic. What we want to do now is make a new one. And I'm going to work from left to right. So I'm going to do that. Let's see here. Maybe I'll put it down over here. So this is going to be for f of x. So whatever's out in front, that's what's going to affect the y column. Right? So negative 2 means I want to multiply all 3 of these by negative 2. So that means I'm going to have negative 2 over e. This will be a negative 2. Right? And a negative 2e. X is plain all by himself, which means we're not touching any of the x values. So they're going to stay the same. And then plus 3 on the end, that means onto the y's, I'm going to be adding 3. So let's talk about what these numbers are. All right, negative 2 plus 3, that's easy enough. That's a 1. So that means we're going to be plotting the point 0, 1. Now, e is approximately 2.7. So you kind of want to think about this as negative 2.7 times 2 would be negative 5.4 plus 3. So it's approximately negative 2.4. This is, again, 2.7. So negative 2 over 2.7, right? You almost want to think about it as negative 2/3. This would be approximately, so you could do that too here. You could have thought that as negative 4/3. Negative 2/3 plus 3, right, would be 2 and 1/3, approximately. And the asymptote, well, whatever we did to the y, we're going to do to him. So 0 times negative 2 is 0 plus 3. So it's y equals 3. All right, let's graph this guy. So y equals 3. 1, 2, 3. That's going to be my horizontal asymptote. So 0, 1 is easy enough. You can't mess that up. And 1 and negative 2.4. So it's down in here. Okay. And then negative 1 and 2, 1/3 out there. Okay. So we know it has the asymptote there. Come down through, hit that guy. And that's approximately what the graph looks like. Now, I always like to graph first because it makes it so much easier to find domain and range. Because now the domain, how far to the left do we go? Well, we're going forever. How far to the right do we go? Well, we're going down forever. Okay. Range, we're going down forever. Hello. To how high? This time we're capped at 3. Okay, so if I know those, I also know these two. I just flip-flop them. So this is going to be negative infinity 3. Negative infinity infinity. Right? That's a great little trick. And now we're going to find the inverse. So the original, I'm going to switch the x and the y. So I switch the x and the y, right? And then I want to get the y alone again. So I'm going to subtract the 3 over. Okay. I'm going to divide both sides by -2. Okay. Another way you could think about this is -x plus 3 over 2. If you don't want to have a negative in the denominator, it really doesn't matter. These two mean exactly the same thing. You can even write it 3 minus x over 2. Now, got to get the y out of there, so I'm going to log it. So the log we use for natural log, for e is natural log. So let me put this up here. So I'm going to write the natural log of e, which you don't have to write, of -x plus 3 over 2 equals y. Now, I can't leave it like this because it has to be in function notation. So that would be the natural log of -x plus 3 over 2. And that's the answer to the question. All right. Now, what I want you guys to get across here is exponents and logs are inverses of each other, right? In number 1, I started off with a log and I ended up with an exponential function. So you flip-flopped. What I'd like you guys to do now is we're going to graph or do together this guy. It's a random equation. Y equals log base 2, 4x minus 1 in parentheses, plus 3. And what I want to do is sketch this. Now, this brings something back in that we talked about in the trig unit, where we discussed how the frequency can never be inside the parenthesis with the shift. So anytime you see a number in front of the x, and it's been a couple of months, I think we did it in November, you need to factor that out first before you can actually graph it. So this not only applies to logs and exponents, but also to trig. And when we start reviewing, you guys are going to see it then. So the first thing I'm going to do is rewrite this as log base 2. I'm going to factor out the 4, and I end up with x minus 1/4 plus 3. All right. Now, we do exactly what we did before. It's just going to be a little more work. We need the parent function. And the parent function for this is just going to be plain old y equals log base 2x. I'm going to make an xy chart for that. Right? Now, in order to graph this, I have to bend it. And notice the y is in the exponent, so that means I'm going to fill in the y column. Anytime it's 2, I like to use -2, 0, 2. You can, again, any 3 numbers. So this is going to be 1/4, 1 and 4. And the asymptote, again, for logs, for basic logs, is x equals 0. And now we're going to do the new equation. Mu e cubed. Okay. I'm going to make my xy chart. Now, I always like to work from left to right. It'll avoid any errors. The first thing I see is the number 4. Now, anything that affects the x, we always do the opposite. So we're not going to multiply by 4. We're actually going to divide by 4. So what we're thinking here is dividing by 4 is the same thing as multiplying by 1/4. So 1/4 times 1/4 is 1 over 16. 1 times 1/4 is 1/4. And the last one would be a 1. All right. So a little check mark. Took care of that. The next thing I come across is x minus 1/4. Now that means I'm going to add 1/4 onto each of these. So I'm going to put that right in front of it like that. Plus 1/4. Plus 1/4. Okay. So I put a check mark because I took care of that. Now I'm going to add 3 to all of the y's. So I'm going to get 1, 3, and 5. All right, so what I'm going to do is clean up this xy table. So I know I have 1, 3, and 5. This is going to be 1 and 1/4. 1/4 plus 1/4 would be 2/4, which is a half. And now this guy is the same thing as saying, we'll get a common denominator, 4 over 16, right? 4 over 16 plus 1 over 16. And that would be 5 over 16. My new asymptote Now remember, anything we did to the x, we have to do to create a new asymptote. So we multiply by 1/4, which 0 times anything is 0, but then we added 1/4. Okay, so now we're going to graph that. Squiggly. Okay, x and 1. My asymptote is 1/4. So since it's so small, I'm going to make that 1. Okay. And then y's, I have to go up to 5, right? So 1, 2, 3, 4, 5. Okay. So my asymptote is 1/4, which would be about there. Okay. 1/2, which is about here. I'm going to be up at 3. At 1 1/4, I'm going to be up at 5. I'm just doing approximates here. 5/16, which is, let's see here, really close to the 1/4 line. We're going to be at 1. So there is my log graph. And you're going to hug this guy going down. And there you have it. So that's the only way I can make these a little harder is for you to recognize that you have to factor out the coefficient in front of the x to be in front of the parentheses. And that, again, is going to be super important for us when we review tree graphs very soon. Because we're almost done with new material. All right, guys, enjoy.